going again. They've given us an even nastier geometric sequence to tangle with here, so let's see if we can do anything with this. The fourth and seventh terms of a geometric sequence are blah blah. Use a system of equations to determine the values of the first term of the common ratio. So basically figure out the behavior of this sequence where we have first term, second term, third term, fourth term, fifth, sixth, seventh. And they've told us the fourth term is negative 54. We don't know any of the first three. And then we don't know the number 5, we don't know number 6, and we know number 7 is 1458. And they tell us the sequence is geometric. So, remember when you're in a geometric sequence, to go forward, you multiply by some number, and it's always the same number. We call it the common ratio. So starting with negative 54, whoever did this multiplied by r, and they got to here, and then they multiplied by r again, and that got them to this next blank space, and then they multiplied one more time, and that got them to 1458. So if we make an expression out of that, we would say, starting with negative 54, if we multiply by r 3 times, r to the third power, that gives us 1458. Well, there's only one variable in that, so we should be able to solve this thing. What if we divide both sides by minus 54? We get r cubed equals 1458 divided by negative 54 is negative 27. R cubed is negative 27, and then if we cube root both sides of that to get plain old r, or you can put it to the 1/3 power if you're happier thinking that way, we get r equals, hey, I know this one, the cube root of 27 is 3, and it has to be negative. So our common ratio is 3, negative 3, sorry. They asked for the common ratio, so good, we have that part figured out. They also want to know what the first term is, so let's see if we can fill that in. Now that we have this r, we can do all kinds of great stuff. We can fill in every blank in this sequence, really, because starting from negative 54, if we multiply by 3, we get 162. And if we multiply by 3 again, we get negative 486. And just as a check, if we do 486 times 3, yeah, we do get 1458, so this part's working. So we can multiply by r over and over to get these later terms. The really fast way to do these previous terms is you can divide by r if you want to go backwards in a geometric sequence. So we could say divided by negative 3, divided by negative 3, divided by negative 3, and keep going until we get to our first term. Now, that completely works. I'm not going to do it that way because what if there were like 700 terms here? We wouldn't want to have to do this manually. Let's see if there's a more powerful way that we can do this with some algebra. We know that this is our fourth term, and we want to know what our first term is. And we have a formula that says any term of a geometric sequence is the first term times r to the n minus 1. N is how many terms into the sequence did you go. If we were doing that here, our nth term, like the term where we're stopping, is negative 54. And we're saying that term is the first term, I don't know what it is, it's just a for now, times r, we just found it, it's negative 3, to the power of n minus 1. N is 4 here. We're talking about a sequence that, we're talking about ending at just the fourth term, so that means because this is about the fourth term, this power is also about the fourth term. If we were using 1458, we'd put 1458 equals a times r to the 7 minus 1. So it's all about which term did you decide to stop at. In this case, fourth term, and then the formula throws in this minus 1 for us. So can we solve that? Negative 54 equals a times negative 3 to the third. Negative 54 equals equals a times, it's a coincidence that we get minus 27 again, but that is indeed what comes out here. And then if we divide by negative 27, we get that a is 2. So this is nice because even if this number had been enormous, we would still be able to work it out with a calculator. We wouldn't have to do a bunch of manual calculation ourselves. So if that 2 is right, then this first term is 2, and let's just check. Times negative 3 times negative 3, and 18 times negative 3 is indeed negative 54, so yes, this whole sequence is working. We've got the values of the first term, it's 2. We got the common ratio, it's negative 3. And they wanted the general term of the sequence. This is the general term of the sequence, but now we can spiff it up because we know all the numbers in it, or all the variables in it. We can rewrite this as the general term of our sequence is a times r to the n minus 1. It's possible to simplify this a little bit. I find the simplified versions of it don't look very good, and they often have fractions in them, so I would hit the brakes right here. If you really want to go one step further, I'll show you this. You're not going to enjoy what's coming now, but here it is anyway. You can write this as negative 3 to the nth power times negative 3 to the negative 1. But negative 3 to the negative 1 is minus 1/3. So, sorry, running out of space. We have 2 times negative 1/3 is negative 2/3. And then we have our minus 3 to the n. I don't think that's an improvement, but if you truly wanted to get it into this form, now you can. I guess you might get a multiple choice question where you get to here and then you check the answers and go, oh no, it's not there. That probably means they expect you to do this next step. So even if you don't like it, make sure you know how to do it. You just take this negative 3 and you say, we have negative 3 to the n. There it is. And then we have negative 3 to the negative 1, which is just a number. And then you combine all your numbers. That's how you do that.